In this video, I'm going to talk a little bit about series and parallel circuits. On the left-hand side, I have a simple series circuit. And I know that it's a series circuit because of one defining characteristic. There's only one place for charge to flow. There's only one path for charge to flow around. At no point in the circuit on the left is there a place where the charge could split into two different paths. And although some of the circuit is cut off from the place where you can see the wires and the battery and the light bulbs, the way that the wires are routed in that circuit on the left looks something like this. This is the positive terminal of the battery. A wire is connected to the positive terminal of that battery, comes around like this, and connects to the one side of that light bulb. And then on the other side of the light bulb, there's a wire that connects to the second light bulb, and then the current would flow through that light bulb and then eventually connect back to the battery on the negative or lower voltage side of that battery. And these, I guess, 3 wires, 2 light bulbs, and 1 battery create a single closed loop. And anytime you have one path along which current is flowing, then you know that that circuit or that part of a circuit is a series circuit. And so now I'm going to go ahead and click play on this video on the left-hand side to show you another key characteristic of a series circuit. What's going to happen is I'm going to remove one of the connections, and you'll see that both of the light bulbs turn off. And when I place the lead back onto the light bulb, both light bulbs turn back on. And the reason why this is important is because if there's only one path for current to flow through, if at any point along that path you remove the connection, if you disconnect something, then you no longer have a closed loop and you no longer can have a current. So one way to identify that you've made a series circuit is if you disconnect one of the light bulbs, the other light bulbs in that branch of the circuit or in that circuit should also turn off. Instead of drawing these complicated circuit diagrams where we have the wires drawn as they would actually be appearing on the desk where I've made the circuit, instead we make simpler schematics that show how everything is connected in the circuit. So quickly, before we move on to the parallel circuit, on the left for the series circuit, the way we might draw that is something like this, where at the top we have a battery, where the longer line represents the positive terminal of that battery and the shorter line represents the negative terminal of that battery. We can draw a conductor coming out of both ends of the battery, and instead of having wires going all over the place, draw a simple box where at the bottom part of this circuit we have 2 light bulbs, and sometimes light bulbs are drawn like this, where we have what kind of looks like a filament with a circle drawn around the outside. And so this circuit I've drawn only has one path for current to flow, and so I know it's a series circuit. And in this series circuit, there is a battery and 2 light bulbs. Now let's move over to the parallel circuit. In the parallel circuit, there are a few extra wires. And so let's see why that's the case. We still have a positive terminal of the battery on the left and a wire coming off the positive terminal of that battery that comes over and is connected to the first light bulb. And similarly, on the negative terminal of the battery, there is a black wire that comes over and is connected to that first light bulb. Now let's explain one key difference between how you hook something up in order for it to be in parallel or in series. If you look at the series circuit, there's a wire that goes from one light bulb to the other. And so if you look at either one of those light bulbs, the 2 wires coming off of one of those light bulbs are not connected directly to the battery. For example, if you consider the light bulb on the left of the series circuit, one of the wires coming off of that light bulb is connected to the positive terminal of the battery, but the wire coming off the other end of the battery first goes to the light bulb on the right and then goes to the negative terminal of the battery. And so we could say that the two ends of the light bulb are not connected directly to the battery. There's something in the way. However, in a parallel circuit, in order for something to be connected in parallel, both ends of the light bulb, or both wires coming off of the light bulb, need to be connected to the battery such that between that circuit element, or that light bulb, and the battery, there's nothing else in the way. And so one way to do this would be to have two wires coming off of the first light bulb going to the battery and two wires coming off of the second light bulb going to the battery. And that would be a simple way to construct the circuit, but I've done it a little bit differently here. Instead, I have a wire that comes off of this second light bulb on both sides, and those wires are not attached to the battery, but this light bulb still is in parallel with the battery. And in order to accomplish this, what I've done is I've taken that second set of wires and I've attached them to the first light bulb. So you might think of it as being something like this. Hopefully you can see that on that first light bulb there are 4 wires. 2 coming off going directly back to the battery, and 2 coming off going to the second light bulb that's below it. And the reason why this works is because when current comes out of the battery, say on the positive terminal of the battery, there is current that comes out this way. I'll symbolize the current with a capital letter I. When that current reaches this point here on the left side of that battery, it has 2 choices. It can either flow through the light bulb, or it can come to the second light bulb. And so the current that comes out of the battery, some of it will flow through the first light bulb, and some of it will bypass the first light bulb and instead go to the second light bulb. And if you consider the current on the way back, say the current flows through the light bulb and now is approaching this junction here, when the current gets to that point, it could recombine with the current that has already gone through the light bulb through the other wires and head back to the battery. But what's key here is that as the current exits the light bulb on the bottom, recombines with the current from the top light bulb and goes back to the battery here, there are no circuit elements between this point and this point. In other words, the current does not have to pass through the light bulb in order to get back to the battery. It simply recombines with the current that went through the first light bulb here and heads back to the battery. Another way that we could draw this is on the bottom. If we want to draw a more simplified version of this, we will have a battery with a positive and negative terminal, and that battery is connected to 2 light bulbs in parallel. And drawing 2 light bulbs in parallel, we can do that in a couple of different ways, but one way to do that is something like what I'm drawing here, where, similar to the picture that I've drawn up above, when the current comes out of the positive terminal of the battery and gets to this location here, it could either go to the first light bulb, or it could come down to the second light bulb. And when the light bulb is when the current has gone through that bottom light bulb and is coming up this way, and the current has gone through the first light bulb and is headed this way, those 2 currents will recombine and head up this way back to the battery. And so in a series circuit, the current kind of stays in one path altogether, but in a parallel circuit there are what we'll call multiple paths. And the reason why it's important to think of series circuits as having one path and parallel circuits as having multiple paths is because if there are multiple paths in a parallel circuit and we remove only one of those paths, then the other path should still be able to contain a current. And so if I hit play on the second video, you'll see I'm going to disconnect one of the wires from the bottom light bulb, and when that disconnection is made, the other light bulb stays on. And so to just summarize everything, a series circuit has one path. If you disconnect one of the light bulbs, the other ones should go out. And a parallel circuit has multiple paths for current. And if you disconnect one of the light bulbs, the other light bulbs should stay on. One final thing that I would like to note is if you have a series circuit, the voltage of the battery is split among the light bulbs that are connected to it. And if you have a parallel circuit, because each of the light bulbs is connected directly to or indirectly to, but without any circuit elements in the way, to the battery, then each light bulb in a parallel circuit will receive the full voltage of the battery. And that is why you should be able to see that in the parallel circuit the light bulbs are much brighter, and in the series circuit the light bulbs are much dimmer. And that's because the voltage applied across each light bulb in the parallel circuit is the full voltage of the battery, and the voltage applied across the light bulbs in the series circuit is only some fraction of that, likely half the voltage of the battery.